So then I'm going to talk specifically about this feature, Clonedb, show you a quick demo of it, and tell you why it's good and why it may not be so good for you. So first of all, what's a clone? Well, for want of a better description, it's an exact copy of something. In this case, it's Dolly the sheep, but for our purposes, we're talking about cloning databases. So taking a database and making an exact copy of that database. Why would we want to do this? Well, there's a number of reasons. We might just want a new version of the same database. For instance, we might be setting up a new environment. We maybe have a user testing environment for a new product, and we want to create a production database, and we do a copy of that. Another reason is the reverse of that, effectively. We might have a production environment, and we want to make copies into a test or development environment to make sure our users have, our developers have up-to-date data to play with. Because I guess we've all worked on systems where we develop an application against tables with like 3 rows in them, and it works really well. We go to production, there's suddenly 1 million rows, and it doesn't work very well at all. So keeping test and development up to date with realistic production style data is pretty important. Cloning allows us to do that. We can also use cloning as a way of testing our backup and recovery system, because if we're using backup-based clones, then we have to have a full complement of our data files present. So if we can instantiate a new clone, it means that we must have got our backups right. It's not a perfect test, but it's something we can use. And I think this is the final point. Oh no, sorry, one more point after this. It's possible to use cloning to create a standby database. Oracle allows us to create a standby, do a duplicate for standby. So we might be creating a new standby database using cloning. And finally, this is not so important now, but in the past, if I did something silly, I dropped a table, I deleted some data, I might have to do a point-in-time recovery of the database, or preferably a point-in-time clone of the database, retrieve the data, and put it back in my production system. That's not so important now, because Oracle gives us a number of flashback technologies to allow us to recover very easily, but you still may use it. So that's why we would. How do we do it? Well, Oracle already give us a number of mechanisms. We can take copies of our data files, move them onto another server, start up a new database on there, do it all manually. That's easy. All these slides are available. I'll give you the URL at the end, so you don't have to take photos if you don't want to, unless you just want pictures of me. So I can do the job manually by moving data files around. I can also use RMAN, Recovery Manager, and use a duplicate command. Prior to 11G, that was a backup-based duplicate. In 11G, I have the ability to do an active duplicate, which does kind of like a backup in the background, moves it across to my server and starts a new clone. But I don't have to have a formal backup. It does it from the live system. So Oracle gives us those solutions for cloning anyway. And then we can buy products from vendors that will help us make clones and replicate and things like that. So we have a lot of... I'm going to get attacked by a fly now. I'll let it live. If he stood on there, that would be fine, because you wouldn't see him. Okay, so we've got lots of mechanisms already available. But all of those cloning mechanisms have similar issues. Firstly, for every clone we want to create, we have more disk space taken. If I have this database here and I want to make a clone, I need copies of the data files. If I want to make 2 clones, I need 2 copies of the data files. So the more clones I make, the more disk space I'm using. Also, the time to perform the clone can be an issue. Some of us have really clever storage layers that allow us to copy files very quickly by doing things like splitting mirrors or whatever. But if you're using regular technology, then you've probably got to copy files from one machine to another, and that takes time, because it takes time for the disks, it takes time for the network. So cloning a little database can be very quick, cloning a massive database can take a very long time. So those are problems we see in all current cloning technologies. Well, traditional cloning technologies. Clonedb is a new feature that gives us the ability to do something a little bit different. So what is it? Let's take a little history lesson. In the first release of Oracle 11g, Oracle released a new feature called the Direct NFS Client. What this does is allows you to use an internal client in the database to write to NFS locations. So when the database is using NFS as a storage layer, it can use its own client that's optimized for Oracle rather than using the client built into the operating system. So that makes it much more efficient. If you're using NFS as your storage layer and you're using Oracle 11g or above, you really should use Direct NFS rather than the operating system NFS client. So that was the first release of 11g. In the 11.202 patch set, so not just the second release of the database, but specifically the 11.202 patch set and above, Oracle included some new functionality, and it's currently not in the official documentation set. But there is a public Metalink note, My Oracle support note, that means that it's actually officially documented, so you're allowed to use it and it is supported. But if you search in the manuals for it, you won't find this feature. Now, Clonedb, this new feature, is built on top of this Direct NFS client, and it allows us to do something quite clever, in my opinion. What it allows us to do is we can use our backup files as a source of our data, and then we can, any changed blocks we make can get written to a new location. So what that means is I can start up multiple clones from the same set of backup files, so I don't have multiple sets of data files. But if I change any data, the changed data gets written to a new location. So just to give you an idea of what's going on, I have my data file image copy backups that I've taken with RMAN or doing a cold backup. I can then start up one or more clones using that as the source. So this stays read-only. This can sit on any file system, local, Samba, NFS, doesn't matter. If I change any data, the blocks associated with that changed data get written to an NFS location, a copy on write location, okay? What that means then is I've got, rather than a normal database where I've got one source of the data files, I actually have two locations. The read-only location and the change data sitting in a copy on write location. So initially, if I start up 10 clones, there's only one set of data files, and then odd little bits written to the copy on write location. So I can save massive amounts of space. And because this is read-only, I can source this from anywhere. I don't have a major problem with performance by doing it over a network specifically. So I've said to you we can potentially save lots of space if we have multiple clones. We have some one-time server setup. I have to do some server setup, but once that's done, creating a new clone is extremely quick, because really we only have to wait for the length of time it takes to create the redo logs. And as I mentioned before, there isn't really any formal documentation on this, but there is one My Oracle support note. If you search on the internet for this, you'll see blog posts by a guy called Kevin Clausen, who used to work for Oracle, and he's the guy that got me interested in this feature. You'll see my articles on this, and this My Oracle support note, and that's pretty much all you'll find on the internet about this feature. But don't let that put you off. This is being used in very big production environments, and it does work. So I'm going to go through a demo now of it. The first bit I'll be talking about the setup. I won't actually demo that live because it's just me typing and it's a little bit boring, but I will do the live clone. So the first thing we need to think of is our copy on write location is an NFS location. If you're using like a proper filer well, that's cool. You just carve some space and present it to your database hardware. But I'm going to use a little Linux VM. What you'll see on this in this demonstration is I have two VMs, if I can find them. Where are they gone? I have one called OL5.11.2, and that's going to be my source server. I have another one called, yeah, there it is, Clonedb, and that's going to be the server where I fire up my clone. So imagine this is a source production server and my clone server. So because I'm just doing it on two little servers, two little virtual machines, I'm going to use the regular NFS functionality to do an NFS share on these Linux boxes. So I create a directory, I put an entry in the etc exports file, and I mount that, I turn on the NFS service and make sure it restarts when the server is rebooted. So this is just giving me an NFS share that I can mount as my copy on write location. It's nothing special. The next thing I need to do is create a production backup. So in this case, I'm going to use RMAN to do, notice, backup as copy of the database, an image copy of the database. That can sit anywhere. As long as my server can read it, or it's a read-only location, it can be on local file system, Samba, NFS, it doesn't matter. So I'm going to do this backup to a local file system on my production server. The next thing I need to do so that I can start up my clone is to create a P file, a parameter file, so the clone can use that to do a startup. So I just do create P file, I'm putting that in the backup location, creating that as a copy of the SP file. If I want to change any parameters, obviously I've got to do that before I start up the clone. In this case, I'm just changing the name to make the new clone have a database name of test. So far, this is all how you would do a manual clone. There's nothing special going on here. On the Clonedb server itself, I have an Oracle installation, and I just have to go into the rdbms lib directory and run this make command. Sometimes make commands do lots and lots of work, like recompiling the whole kernel or something. In this case, all this make file does is swap a couple of files around. It takes a split second. And then I need to create some directories on this file on this server. Why? When I start up the database, any directories in the parameter file that are referenced in the parameter file have to be present on the file system. So all I'm going to do is create a couple of directories, like an Oradata directory and some admin directories, and I'll show you that. Okay, so I've got some directories I'm just cleaning up in case I've run this demo before. I'm creating a copy on write location. That's going to be the location I mount onto my NFS share. I've got a fast recovery area for my test database, and I've got a couple of directories in the admin directory. So all of those things get referenced in my parameter file, my initialization file, so they've got to be physically present. So I've created those. Once again, this is just the same as you'd do for any regular clone at this point. And I mount the copy on write location, so I now have a location where my changed blocks can get written. So all of that is the setup. I do that once, and from now on I can keep using the Clonedb functionality to do the cloning. The only difference to doing this manual clone is the fact I've turned on the direct NFS client for my clone installation. So let's actually do some cloning. The MyOracle support note I mentioned to you, the number is in that in the slides, has got a little file, a Perl file called clone.pl attached to it. If you download that, you can use it to generate some scripts for you, and I'm going to show you that now. I've got a little script here that calls it, and I'll show you what that script does. This is the file that you can get from Oracle, from that MyOracle support note. It's called clone.pl. It expects 4 environment variables to be set. Oracle SID, which should be obvious if you ever use databases. Master copy dir, which is the location of the backup files. Now, these are on the production server, but I'm going to mount a directory against that on my clone server called /uo on backups. I need my clone file create dest, which is the copy on write location, which I've mounted. And then I need the database name for the clone. So I've decided to make the SID and the database name test. On my original production instance, it was db11g. I then have to move my init.aura file into a location somewhere. It doesn't really matter where, because it's going to get moved again by the script. But in this case, I put it into the Oracle Home DBS directory. Once I've set that environment up, I call the Perl script and pass in 3 parameters. The location of my initialization parameter file, and then 2 file names that it's going to create for me. And they're pretty simple, you'll see. So I'll run that now. And that's, oh, actually. So that's how long creating the script took, almost instantly. So let's have a look what it's generated for me. Well, I've got a startup no mount using a P file, so it's copied my parameter file into this copy on write location. It's actually added a couple of parameters into that, but all those are the OMF parameters, the Oracle Managed File Parameters. And then it's created a control file creation script for me. If you can see that at the bottom, in the data file section, every one of the backup files in my UO1 backup directory is referenced in there. So as far as my database creation is concerned, I'm using the backup files for this, the image copy backups. Now I said to you earlier, the speed of cloning is based on the size of the redo logs and how long they take to write. So I'm going to cheat and make these a bit smaller so it's quicker, because this is only a rubbish laptop. The next script it's generated for me is where the magic happens. So it's got calls to dbms dnfs clonedb rename file. Now it's a bit of an unfortunate name because we're not actually renaming the file. What we're doing is associating a copy on write location with the backup file. So this is the backup file where all the data is being sourced from, but it's read-only. If I write any data, then I want it to write to this copy on write location associated with it. So really that should be called clonedb associate file, because I'm not renaming the file. Once I've done all that, I'm then going to do an alter database open reset logs. The time it takes to clone is the time it takes for that to run. Okay? And we'll see that's pretty quick, unless my laptop dies. There's then 2 lines that I'm expecting to fail. It's trying to manage the temp table space. If you know anything about the temp table space, you'll know that you can't drop the default temporary table space. And that's exactly what it's trying to do. So we'll get 2 errors at the end, but don't worry about that, I'll fix that. So I run the script. It does my startup no mount. That will scroll up, don't worry. As soon as I do the startup no mount, I do the create control file. Then I run this associating the backup location with the copy on write location. And at the bottom now, I'm doing an alter database open reset logs. So this is actually performing the clone now. And you'll see that's finished. I have a clone database. Notice the 2 errors that I got, which I said I would, managing the temporary table space is wrong. I'll show you what you've got to do for that in a moment. But you saw how quick that clone was. I now have a fully functioning database, and I'll show you that in a moment. So we've done that, and I've run that. Now that was a hot backup I used to create my clone, but I did it on a very quiet system, so the backup files weren't fuzzy. If I'd done it on a busy system with lots of DML going, the backups would be fuzzy and I'd have to recover them. In that case, I'd do a recover database using backup control file until cancel, and then the open reset logs. So we saw the errors managing temp. So what I've got to do is actually do the temp management properly. The script should contain this, but it hasn't been updated. So what the script should have done is created a new temporary table space. It should have set that as the default temporary table space, dropped the old table space, and then maybe renamed it if I wanted that to happen. If those 4 statements had been put into the cloning script, we wouldn't have had any errors. I've actually told Oracle about this. They haven't updated it yet. But it's no big deal. So the question now is, how does the database see its file system? Does it understand what it's doing? Does it understand that it's not really using the backup for its writing change blocks? Well, let's have a look. So if I look at the $v data file view, it thinks that it's using the copy on write location for its data files. Well, that's a bit of a problem because I'm telling you there's not really anything there at the moment. So what's really happening? If I look at the underlying file system, I can see. So in my UO1 backups directory, I've got the backup files that are being used as the source of the data, and that's the size of them there. Okay, this is just a default installation, so it's not very big, but you can see those file sizes are bigger than these file sizes at the bottom. These file sizes are the files present in the copy on write location. So actually I've got a fully functioning database. I can use it just like any other database, but when I read data that's unmodified from the backup, it comes from the backup files. When I change any data, do an insert, update, delete, the change blocks get written to this location. Now imagine this was a 10 terabyte database and I wanted to do 10 clones of it. I probably wouldn't have files much bigger than this when I start the clone because hardly any data has changed. So you can see that this gives the potential for massive space savings if you're doing lots of cloning. But of course there are caveats which I'll get onto. So some considerations. The copy on write location is an NFS location. If you don't like using NFS in your organization, if you're not allowed to use NFS in your organization, you can't use this feature. But you don't have to go out and buy a big expensive filer to do this. You can see I've used it on a VM, on a rubbish little Apple laptop. So if you've got a decent sized server with an NFS share on it, even from a Linux system, it will work. I'm nervous about using this type of cloning where performance is concerned because not only are we using NFS, but it's actually using a different code path to read and write the data. Normally, if you want to write a row to a table, Oracle knows exactly where the data file for the block is located. In this case, the direct NFS client has got some extra code in it that helps us here because it says, oh, you want this block from a file. Is it a change block or is it one that hasn't been modified yet? Oh, it's a change block. I have to read that from the copy on write location. If it isn't changed, it'll read it from the backup. So there's some different code path happening here. It's all hidden from the database kernel itself. It's all done in the direct NFS client. But it is different. So comparing the performance of your production system with this clone is probably not sensible. That's not to say it doesn't perform well. It does. But you've got to be careful when you're comparing two systems that you are comparing similar things. Space savings. I've told you that I don't need to write many new blocks when I perform the clone, but be aware that if I carried on updating the database, more and more blocks would get written to the copy on write location, and therefore eventually all of the blocks would be in that location, and my comparable space saving would be nothing. And also remember that you have to have image copy backups in order to use this feature. You can't use backup sets. So if your current backup schedule does backup sets, then you'd have to take an extra backup, which is another copy of your data. So depending on how you use it, depends on how much space you save. Other things to consider. Very little documentation around. I've told you that already. That scares people. It shouldn't. This works really well, but some people get nervous. It's a very new feature. Lots of people work in departments where they won't use a feature until it's about 10 years old. Yeah? If you're in a department like that, you're not going to use this. Where would I use it? I suppose the question really should be, where wouldn't I use it? Because I think it's pretty cool and I use it a lot. But I think it's fantastic for short-lived clones. I need to clone a database, do something quick with it, throw it away. I can clone really quickly with this, or I can wait several minutes, hours, days to do a traditional clone. So for me, this one is great for very quick turnover of clones. I could use it to test my backups if I wanted, you know. Because it's so quick to create a clone, if I didn't have flashback features available to me, I could use this to do a quick clone, a point-in-time clone, recover my lost objects and throw it away. Much faster than doing a traditional duplicate. I've already mentioned really where I wouldn't use it, and that's for performance testing. I'm nervous because if I've got my production system on a SAN and this using Clonedb against an NFS location, the storage subsystems are so different. Can I really compare the two? So that would make me nervous. But if I'm setting up a clone that's going to live for a long time, like a new environment that's going to live for the next year, the amount of time I save by using this feature proportionally divided over that time is irrelevant. So if I was doing a regular clone that was going to live for a long time, I'd probably use an R-man duplicate. If I was going to do something quickly for a quick test and throw it away, I'd use Clonedb. You can't use it for setting up standbys because it just doesn't work. So forget that straight away. So in summary, why are you playing up? Yeah. In summary, very quick. Now I'm aware that if you have a storage technology that allows you to do super quick copying of files, you may have another way of doing such quick cloning. But if you don't have access to that sort of storage technology, this is one of the quickest ways you can get a new clone out. Potential space savings depending on how you use it. But remember, you need to be on the second to latest patch set. It needs to be on 11.202. Don't email me and say, as someone did the other day, I loved your talk, how do I do this in 11.201? It isn't going to happen, okay? You have to be on this patch set or higher. And remember, the copy on write location has to be NFS. If you don't want to use NFS, you can't use this. Now, slides are available, but I would suggest that slides aren't really the best place to go for the information. If you go to my website and do oraclebase.com/workshops, you'll see Clonedb, slides, demos, and article. The article is far easier to follow than the slides because it's got all the explanation in. And that is, oh no, here we go. So you'll see there's an article on my website with all of that stuff explained. Yeah. So that would be a better source of information rather than the slides. But if you want the slides, go ahead. So that's the talk. That's me done. Questions. First question was external files. So you mean, for instance, you've got an external table and the files associated with that external table you want to be able to read in your clone. Yes. The database, backups, anything like that, don't take external files into consideration. So you'd have to move those manually across, but the definition of the external table will be in the database. So if you put the flat files in the right location, they'll be totally usable. The database doesn't know it's using the copy on write technology. Direct NFS client hides that from the database. So the database thinks it's just another database. Okay? It's running completely normally. It's the direct NFS client that changes things. Anything where you can get an image copy of the data files, you can use as your source. I could turn the database off to a cold backup. I could do an R-man backup. I could use a third party to snapshot the files and use that as long as they were a clean cut rather than fuzzy. So yes, I could turn off my standby, or do a backup of my standby and use that as a source. That's fine. Yeah. As long as you've got an image copy of the data files, this will work. Have a go with it. Play with it. You can do it on a PC. Get used to it. And I mean, if you're a geek like me, if you do cloning as part of your regular job like I do, I think you'll love it. If you don't do cloning, what the hell were you doing here? Okay, so thanks very much. I've got a talk this afternoon, and it's listed on the program as being the same talk again. I'm actually doing a talk on edition-based redefinition, which is a PLSQL feature. So if anyone wants to come and stare at me again and watch me wander around the stage like this, then come back this afternoon. So it's not the same talk again. Okay, thanks very much, and I'll see you soon.